Welcome everybody to the September, almost October, but September City DevOps Meetup. I am Lindsay. I'm Oxesis on Twitter over here. I run this thing. Before we start, I would like to acknowledge the traditional owners and custodians of country throughout Australia, which in my case is the Duck and Young people, and recognize their continuing connection to land, waters, and cultures. We pay our respects to their elders, past and present. So, as I said, welcome to the September meetup. It's lovely to have all of you here. Quick refresh on the code of conduct. We have one. It's very easy to enforce when we're online, so we don't tolerate harassment of meetup participants in any form. We expect that all communication is appropriate for a professional audience, and harassment, sexist, racist, or exclusionary jokes are not appropriate at this meetup. I have not had to boot anybody out of this meetup before, but I had to at another meetup a couple of months ago. So that was exciting, having somebody quite hostile join and start doing dumb shit. Anyway, not having any of that. Eventually, we punted them out. So tonight's agenda, we have the intro, which is the thing that I'm doing right now. We're going to then roll into talk number one. We've got an events job section that we're going to sandwich in the middle there, and then we've got talk number two. The jobs, the way that that's going to work, if you're looking to fill a position, either you're hiring or wish to be hired, you'll have 30 seconds. So feel free to use the chat function just to let me know ahead of time, and we'll form a orderly queue virtually. Normally we do it physically in person, but yeah, you'll have 30 seconds to unmute and talk about yourself or talk about the job that you are, or the position that you're trying to fill. Yeah, there we go. So tonight's talks, we've got two fantastic talks lined up. We've got Halvard talking about building containerized Go apps with Skaffold and Co. And we've got Pedram talking about container privilege escalation, which I'm definitely looking forward to seeing. In fact, I'm looking forward to seeing both of these talks, to be honest, but yeah, they're both going to be great. All right, so before we dive into that though, who here is a first timer? Feel free to either, use the reactions in Slack and put your hand up, or pop something in the chat. It's up to you. Occasionally we've got first timers here. Hey, we've got Pedram. Your debut is actually speaking as well, so extra bonus points for that. Nice work. We've got Julia and Shekar who are both saying that's the first time. Lovely to have you here. And while you're at it, actually, first timer, what's the furthest away that people have come? I'll lead with that. I don't actually live in Sydney. I have not lived in Sydney for the majority of time that I run the City DevOps Meetup. I live up on the Central Coast. So, fantastic. Good. Julia, who's joined, who's coming in from Brisbane. Lovely to have you from so far away. Glenn is only from Perth. Well, Perth is still pretty far away. So that's one of the nice things about having been able to do the online meetups for the last couple of years, and that we've expanded the scope. Oh, we've got Kit coming in from Auckland as well. Lovely to have somebody from another part of the world. Brilliant. Ancestry does not count, not today at least. But that's a great question, Victor. Thank you for asking it. Occasionally we have people that are waking up in Europe or the Middle East or Africa, and they join. So it's lovely to have them whenever they're here. All right. Well, Glenn, I think you might win. Sydney's inner west. I mean, that is pretty far away, you've got to say. I think Glenn might actually win, but only by a whisker, because Kit being in Auckland, I think Perth is still a little bit further away than Auckland. So congrats, Glenn. You win the prize, of which there is none. All right. For the time being, we're sort of going to continue with these online meetups. There may be an occasional in-person meetup, but just make sure that you're practicing good mask hygiene and social distancing, and get your booster if you're able to. But yeah, looking forward to getting to some in-person, face-to-face meetups sometime soon, hopefully in the next month or two, actually. The online format seems to have worked pretty well for us, so it's going to be interesting as we sort of transition back. We may continue to try and do online meetups, say every second meetup, or maybe hybrid. I don't know, is the short answer. I don't know, and it feels like almost every week I have a different opinion on it. So this is working. We're going to stick with this, but maybe the occasional online face-to-face meetup. All right, that's enough of me rambling. I'm just going to dive straight into it and pass the mic to Halvard, who's going to be talking about building containerized Go apps with Skaffold and Co. I'm going to stop my screen share, and then Halvard, take it away.
All right. Thanks, Lindsay, for the introduction, and thanks everyone. So I'm a long-time listener, first-time presenter. I think the first Sydney DevOps meetup I attended would have been back in 2011, and there was a presentation on the FPM package manager tool. I guess here we are, more than a decade later, still talking about packaging. So it's interesting parallels there. Yes, anyway, my name is Halvard. So I'll be talking to you about how to easily containerize Go apps using two tools that I've been working on a fair bit recently. Before we get into that, though, just going to set the scene very quickly, where when you develop containerized apps, and often you would deploy that to something like Kubernetes, that can be a very manual and tedious thing to do, right? You have slow feedback loops because every time you make a change, you need to build a new container image. You might want to tag that container image, push it to a registry, update your deployment manifests, apply those new deployment manifests, set up some port forwarding, and start tailing logs. And then you make another change and repeat the process. If you have either microservices set up or maybe a distributed monolith, then even more challenging. So this is where Skaffold comes in. Skaffold does many things, but one of the things it does is basically reduce the toil and the tedious and repetitive nature of having to iterate on a containerized app that you want to run in a Kubernetes cluster. So the sort of sequence of commands, or some similar sequence of commands that you see on the left, basically boils down to running a single command, scaffold dev, which starts basically which builds the container, deploys it, starts a watch loop, and so when you make changes to your code, it automatically rebuilds, pushes a new image, redeploys it, and you can continue on and inspecting what impact you made by the change that you made to your code. So what is Skaffold, actually? It is an open source client-side only tool. So this is something you can use without installing anything in your Kubernetes cluster. And it's designed to help you develop, build, and deploy essentially container-based applications to Kubernetes, but also to a couple of other runtimes as well. It's a tool that does a lot of things, and today we'll only be looking at a very small and focused part of it, which is specifically around building, developing, and debugging Go apps. Now, we also said that we're going to use Co for this. So Co is one of the many builders supported by Skaffold. So you see here on the left section, you can use many different builders to build container images with Skaffold. It's pluggable in that sense. And Skaffold goes beyond just building container images, where you can also render or manage your Kubernetes manifests. So you might want to run your manifests through tools like Helm or Kept or Customize, or maybe you don't. And also use various different tools to deploy. Beyond that, you have features like profiles to help you manage what you want to do in, let's say, your prod environment versus your staging environment, strategies for tagging, and a whole lot of other things. But today we'll be looking at this one part of it. So I mentioned Co a few times without actually saying what it is. So Co is another open source tool. It is both a command line tool and also a library for building container images for your Go applications. So Co is fast, and everyone loves a fast build, right? It's reproducible, and this is very important for some of your more sort of security conscious people. So what we mean here by reproducibility is actually byte for byte reproducibility, as in you can run the same build twice and you get byte for byte exactly the same output. Configurationless, so you don't require any configuration, which is an almost true statement. You do need to tell Co where to push the container image that you build. So whether that be a local tarball or an image registry, or you want to load it into your local Docker daemon, you do have to, there is that one bit of small configuration required. Code doesn't require Docker, it doesn't use Docker to build images. And it doesn't also need a Docker file. So what that means is that if you have a microservices set up with 20 different services, you don't end up with 20 subtly different Docker files because everyone copied the Docker file from one service to the next and made some slight tweaks because they heard that, hey, running as root isn't great, so we probably shouldn't do that. We should reorder the steps, such and such in order to optimize for caching, etc. That sort of problem goes away with Ko. And if you need to build images, multi-platform images, so you need to build for Intel and ARM and other platforms, that's trivial with Ko. And we'll look at that very shortly. So there are a bunch of open source projects that use Ko. Knative, Tekton, and the Sixdoor project are some of them. I'm sure there are many others as well, but these are some of the more notable ones that I know of. Ko actually came out of the Knative project, but that's a history talk for another time. So Ko is, as I mentioned, is both a command line client and a library. Using the command line client is fairly straightforward. So we're basically talking about changing a single character in your workflow here to go from building a Go binary for your app to building a container image. And if all you want to do is just build an image, that's great. That's awesome. But this is a DevOps meetup, not the Ops meetup. So I assume that there will be people here who are interested in not just building images, but actually developing the code that goes into those images, right? And to do, when you do that, you might want to see what happens when you make a change and have a workflow around that. You might want to do some remote debugging. And that's where essentially the combination of Skaffold with the Ko builder helps. Because Skaffold and Ko go so well together that actually Skaffold embeds Ko as a library. So if you have Skaffold, you can build images with Ko already without downloading any other tools. So I mentioned that Ko didn't require any configuration. Skaffold does require a little bit of configuration where basically you have to tell it which images you want to build and how you want to build them. But if you take an existing Skaffold setup and you want to use the Ko builder, what you see here, this little line here is the only thing you need to change in order to switch to using the Ko builder. No need to download any additional tools. It's all available there for you. So anyway, I was hoping that this would be more about actually showing things rather than me just blabbing on. So I figured we'll show how this actually works in practice. So let's switch to the editor here. Right. So here we have a very simple Go app. It's a web app that just listens on port 8080 and returns hello world, and that's it. We do have some Skaffold configuration here, not very much. Basically just saying that here's the name of the image we want to build, make up whatever name you want, and we want to use the Ko builder. So let us try to build that image. So we say Skaffold Ko, the tag strategy kicks in, and we build an image and we push it. In this case, we push it to Google Artifact Registry, and that's done. We have our image. By the way, I've disabled caching, so there's no magic happening behind the scenes that speeds things up here. Now that was a single platform image. Let's clear that away. Now we can also build a multi-platform image, which is pretty straightforward. Let's say we want to build for Intel and we want to build for ARM as well. So you see here, we're targeting 2 platforms in this case. And now we published a multi-platform image with a manifest list to go along with it. And if we want proof of that, so we can grab this image here that we got and maybe take a look at the manifest. Make it a little bigger. So here's our manifest list with our, did I copy the wrong one now? That is not a manifest list. Live demos, gotta love them. Let's try that one instead. No, okay. First demo fail. Anyway, moving on. I promise you that was a multi-platform image. All right.
When you compile it, I think the next one was, instead of ARM64 was again AMD64. Maybe that was the reason.
Thank you, Pedram. Exactly right. Okay, let's repeat that again.
At least one person's paying attention in this demo.
Yes, so now we see 2 building steps here. And let's try that one again. Yes, we have our manifest list. Thank you for that, Pedram. Thank you for the save. Oh, all right. So that's build. That's just building an image, and that's great. But let's move on to something a little more interesting. And let me switch the window here. All right. So the dev workflow that we talked about before, where we basically watch for changes and rebuild as required. So let's take a look at that. So we still use the same demo application. I haven't made any changes to it. What I have set up is I've set up a Google Kubernetes Engine cluster running in the Sydney region. So I'm going to be deploying to that. So that's why you can see here I've set up my kube context to point to that cluster. Okay, so I run Skaffold dev. And so what will happen here is you'll see here while that's building, you'll see here I have a simple deployment resource defined and a simple service as well. So Skaffold picks up those manifests and uses those to deploy. So the image has been built and has been deployed, and we've set up port forwarding here to port 4503. So let's do a curl to that. And we see hello world, which is great. And what we can do now is we can go back to our application here and say, make a change. And obviously capital O is important, and we save this. So you'll see here in the terminal that Skaffold has picked up that change. It now wants to rebuild the image, push it to the registry, and redeploy. Should be ready any moment. All right, so let's try that again. And we've changed our application running on the GKE cluster. Right, so let's clear that. Okay, so that's development, and that's great. Now, remote debugging is another feature that's often very handy when you do development, right? Things might work fine on your local machine, and then you want to push it to an environment which has a lot of other services and dependencies running, and things fail there, and you can't understand why, and so you want to do some remote debugging. Now, in order to do that, you would need to add the delve debugger to your container image or to the pod somehow, right? Make sure that you compile with optimizations disabled, because you don't want to optimize when you want to debug. You need to patch the manifest so that you launch your application using the delve debugger and apply that and forward ports, etc. And that's what you need to do. Or you can just run Skaffold debug and that takes care of all of these steps on the left for you. So let's give that a go. So again, same application, haven't made any changes to any configuration here. Debug port forward. I'm going to guess that the port forward will be the same port again. Come on, okay, yep. Debugging messages, etc. Okay, so the app is running, that's great. Now what we can do now is if we set a breakpoint here and hop into the debugging section and attach the debugger. Ignore the error that you see. So with our breakpoint in place, we should be able to now send a request again, and we hit our breakpoint, and we can, inspect the local variables, the call stack, etc. So again, Skaffold debug here together with Co basically did all that for you. If you use Skaffold with other builders, you do need to take care to make sure that, if you develop for Go, you disable optimizations and things like that. But with the Co builder, it's all taken care of for you. Okay, let us disconnect here. Let's get out of this. Right. That is the right window. Yep. Okay, so that was Skaffold debug. Now, if we still have time, there is actually a little sneak peek that I wanted to share with you. So what I've shown so far is all available and ready for use already. But we do have a new proposed feature, which we have an implementation for. It's a prototype implementation, so it's not anything that would pass code review anywhere, but it works. So essentially, what you saw previously with the Skaffold dev command, where we watch for changes and we rebuild, that's great, but there is some overhead involved here, right? Because we have to compile the binary, build the new image, push it to the registry, update the pod spec, and then the kubelet has to download this new image and create a new pod. And Skaffold automates that, which is great. But still, it's not quite snappy enough to feel just like local development, because there is some latency involved, mainly due to all the network hops here. And if, let's say you have a slightly more complex setup where, for instance, you have an init container in your pod that does certain setup at startup time, then you would feel that sort of pain due to the latency even more because you get a new pod each time. So what if we could speed up that loop even further so that it really starts to feel just like local development, even though we are working on a remote cluster here? That's what this sort of proposed feature is about, basically a hot reloading of the running binary on the remote cluster. Be keen to hear your feedback on this and whether you would find it useful. So before I continue, let me switch back to the code here and let's get at this one. So here's for a little sneak peek here. What we have here is we have basically the same application again. But we do have a slightly modified manifest here where basically the key part that's different here is we want to enable syncing. Otherwise, the application is the same. So let us run the special build with the experimental feature. So if live demos, weren't sort of scary enough already, live demoing kind of, prototype features of proposed functionality is even more exciting. we're building our image with a slight tweak to before. But what I'm going to do here is I'm going to set up a watch loop. Okay, so I'm going to set up a watch loop that sends a request to the port that we forwarded here. And if we go back to our application here, so we see hello world, so hopefully that's what we will see here. Now this polls every 100 milliseconds or so. So let's see how fast we can make a change, and I hit save. And the app running on the GK cluster has been updated. I didn't time it, but I think it was faster than before. So that's it for that demo. While I switch back here. If you like this or have any input on it, feel free to go to this very easy to remember URL. Basically, that's where you'll see the proposal for it, and leave your comment there. Maybe there's a way, Lindsay, to, I don't know, stick this link into the Meetup notes or something. But yes, please feel free to give your input here so that we can figure out how to prioritize implementing this feature.
I want to introduce you to a little feature of Meetup called comments. So just leave a comment on the Meetup event, and other people who are here should be able to find it. But also thanks to Juan for who's already put it in the chat as well. Thank you for that.
Brilliant. Thank you, Juan. All right. So that was. Yeah.
No, I was going to ask if there are any questions, but you clearly haven't finished your talk, so I'm going to let you finish your talk.
Well, yeah, I have finished my talk, so I am ready to take any questions that people might have.
Feel free to pop your question in the chat as well if you don't feel comfortable speaking up and unmuting, and I'm very happy to ask it on your behalf as well.
I have a question.
For it.
For the Skaffold debug, was there any change to the config? Or was nothing? Was there any change to the config? No.
So config, no. So let me switch back to the this one here. So let's control this stuff here. So for debug, I was using this this config here, the Skaffold config. There was no change, no. So Skaffold basically takes care of what actually happens under the hood is Skaffold detects that you're building a Go application, because obviously Skaffold doesn't work just for Go applications, right? You can build all kinds of containers with Skaffold, not just Go, but Skaffold detects that it's a Go application, and it rewrites the manifest to add an init container, which then copies in delv and sets up delv with all the parameters as the command of the container, and also sets up the port forwarding, not just to the application, but also to the debugger, to the delv debugger.
Curious how, sorry, you go.
No, that was really crazy fast. Like when you were demoing, I wasn't sure. Thanks for confirming the cache was disabled.
That debugging workflow, how does that work for languages that aren't Go?
Yep. So there's basically separate implementations for each of the languages that are supported. There is a, it basically, I'm trying to remember off the top of my head now which languages are supported for debugging, but basically it's language specific implementations. With Java, it's a bit simpler because you just kind of, enable debugging and open the ports. I don't have too much experience with other languages, but basically the key is that Skaffold needs to be able to detect what kind of image you're building. Now, if you're using a co-builder, then it knows it's Go. If you're using the Jib builder, then it knows it's a JVM language. But if you're using Docker, it could be anything, right? So then you need a way for it to detect what it is and to inject the right debugger. or to configure the manifest for debugging.
Yeah, that's great. Thank you. All right. Any other questions before we wrap this one up? All right. I think that might be it. Thank you very much, Halvard. Great talk.
Thank you, everyone.
Brilliant. And there's some nice comments left in the chat that you can go and bask in the glory of when you when you got a moment, Halvard. All right, events. Let's do this. Just a couple of upcoming events that are happening in the region-ish, in the next little while. So we've got SRECon APAC that's happening in December. So it's December 7 to 9. I believe that they are announcing their program this week. But I was actually on the paper review committee for that. The quality of the talks there is phenomenal. So if you are in any way interested in site reliability engineering, both the technology and the culture, it's definitely a conference that you should look at attending. Some really fantastic talks that are going to be coming up at that. So I highly recommend. Otherwise, there's YAO as well that's happening just a couple of days later. So that's on December 12 and 13. Yeah, I think they're doing one in Melbourne as well, and possibly Perth. I didn't actually grab the details of that, but if you haven't been to YAO is developer focused. They often get really good international speakers in as well. And yeah, I highly recommend you attend that if you're interested in sort of getting a finger on the pulse on what's happening in the dev world at the moment. Glenn, I noticed that you just popped something in the chat there about, oh, okay. Thank you, Glenn. Glenn asynchronously has said, YAO Perth has been and gone. Well, I will just get in my time machine and instruct past me to mention that in one of these meetups. Sorry. I've made you all happy with the dead bird. I'm sure YAO Perth will be back next year. But Glenn, do you want to talk about DDD Brisbane at all?
Actually, not really. I was told that I should probably submit a talk, but we recently had DDD Perth, which is the developer conference. Interestingly, the agenda is actually made by voting. So the community actually votes on which talks they would like. So you actually get some really good local speakers talking about local stuff and some internationals now that our borders are actually open. Good community conference. And I think we've got some Queenslanders in the call, so they should definitely check it out. And it's like $60 for the event.
According to the website, it is only $49.
$49, 60 Australia, 60 Perth dollars. So there you go.
That's right. Inflation is a bit different over there, the exchange rate and everything. Yeah, and I just checked. That is on Saturday, December 3.
And CFP is still open for another 4 days.
Fantastic. So if you're thinking of attending or speaking, get in quick. All right, thanks, Glenn. I don't think I've got any other conferences that well, how would I know if I got any conferences that I've missed? Because if I had them, I would have put them in here. If you can think of anything else, feel free to pop it into the chat and I'll give you a moment to speak about that. All right, jobs. So if you are looking to fill a position or looking to fill a position, 30 seconds to do that. So if you if you're hiring or you're looking to be hired, now is your chance. Feel free to pop your name over in the chat there, or just unmute and take a swing at it. All right, we've got Matt in the chat who's just popped up and said 9 is always hiring for engineers. Matt, do you want to speak to that for a little bit?
We can do. I hope my audio is coming through. I'm on a different laptop.
It's great.
Excellent. So 9, I'm involved in the platform engineering team at 9. So we actually make 9, Sydney Morning Herald and all that stuff work. We have, I'm not sure if we currently have a role or two open, but there's some teams we work with that definitely have some roles open. So if you're interested in working at 9, working with some interesting technology, have a chat to me.
And Matt is good people as well. So not only do you get to work with interesting technology, you get to work with interesting people too.
Well, there's other more interesting and useful, good people to work with than just me. So
That's just what somebody who was interesting would say. All right. Feel free to pop any other jobs that you are hiring for, or yourself, if you're looking for work. Feel free to speak up as well. Pop that either in the chat or unmute and take a swing at it. Otherwise, I'm going to give it 5 more seconds. We're just going to keep rolling into the last talk. All right, cool. Well, that's it. Apparently, 9 is the only place in all of Australia that is hiring for DevOps related things at the moment. So congratulations, 9. You win this round. All right, we're going to roll straight into the next talk here. We've got Pedram talking about privilege escalation in containers. I'm going to stop sharing and Pedram, take it away.
Okay, thank you. So being first time here, please be nice.
We're always nice. And if we're not, I'll boot out them.
So kind of trying to figure out where is the technical level of the audience are. So this talk has 3 levels. I'm going to start with the level 1. Depending on how time goes, I'm going to move on. So forgive me if some parts that are like, oh, come on, I already know about this. So my name is Pedram, and I'm founder of a Sec team. We are an open training game. We have an open training game for secure programming. So which came out of my developer security training that I was running for the past 10 odd years. That we need more people helping us to fix security bugs. I was the guy who was a security auditor and doing a lot of code review for companies, always pointing at the problem. Oh, here is the security bug. Here is that. Why you don't do anything about it? Then I realized more and more that fixing is way harder than finding those problems. So coming from that background, just one thing quickly, the game that I just talked about, it's open, it's accessible to the community. I'm just going to pop the link there. I will be going through one of that games throughout these talks, so feel free to follow along. So a few things that I'm going to talk about, this is actually come from some of my own code reviews that I did on some infrastructure code. First of all, why container security is important. Let me just demystify a few things. Most likely you know what they are. Containers does not equal to security, nor sandboxing, nor segregation. And container, although it may sound conceptually that we containing something, is nothing to do with even virtualization. Now, I'm saying that because maybe some of us may still think, oh, it's contained, so the thing that I'm running there is safe to run. Behind the scene, container is just another process that runs on the host, and that host could be a Kubernetes cluster or my desktop Linux. But that process obviously will use effectively behind the scene 2 kernel features. One is being namespaces, the other one C group. So effectively, when I'm running a Flask app or a Django, I don't know, a Go app, that process runs by a parent process, which is a container, and that parent process can limit the world view of the child process. And that's it. And like many other processes that we have on a system, a process needs to run with a user. So that's like by convention. So now with that in mind, the first thing I just wanted to get out of the way was, let's just remember, container does not mean security. So we need to take extra step to make them harden. And unfortunately, they don't come hardened by default. There are 3 things we need to look at when it comes to the container security in general. So I just specify them in the 3 groups: container registry security incidents, container daemon, and insecure configuration. Let me start by this, and this is the many incidents that happen to any container registry. This one is specifically for Docker Hub. It was around April 2019. We had around 190,000 Docker accounts were leaked, were exposed, including the tokens that was used to deploy, the CI/CD tokens that was deployed to push those images to the Docker Hub. Now I understand some enterprises, they stop using Docker Hub altogether, but it's not bashing any container registry. This is just that something will happen. And unless you're building all your images from scratch, less likely, or even distro-less, we are relying on some of these official images that come from somewhere. So what can we do about this? Well, I would say 3 things. Firstly, like many security incidents, keep an eye out. If things like this happen, like some companies, like specifically for this breach, some companies like Microsoft, they actually went out and tell people that, hey, our images are not damaged, they're not tampered, you are still safe to use them. Normally vendors, they will come out and say words, because specifically for Docker, that incident, those tokens that was used for deployment was leaked. So there could be a potential for an adversary to go and change something in our Docker images. So that's something like we're just relying on vendors to help us to figure that out. But we are not limited there. Most likely you heard about the digests for every container image. It's simple to dig it out. Like this is just a sample container image I have. And you head to tags, and then you can see a digest of it. You can even get it under using your manifest. But this is effectively, this is just a checksum of the content of that image, right? So it's a lot better that we use this SHA-2 checksum when we are using from image something. Now, some of the linters these days, if you run against your Docker container or Docker files, they actually call out that, hey, I mean, back in the days was like, hey, you specify latest is not good, just pin it to a version. But nowadays they're like, no, don't even pin it to a version, just include also the digest. So this will allow us to stop some of the, if the integrity of that image, so someone tampered it and something changes, obviously this digest will change, and that the engine will not load that container. If you want to go one step further, there is a evolving community around signing images at the moment. It's not that popular at the moment. It's not that super also simple from the toolings that I looked at, but you guys can correct me on this. They're not that much of a simple to even deploy at the moment, but effectively, think about it. You have a digest which is signed by the private key of the vendor. So that kind of take the security of that image to the next level, because even if a container image is tampered because it's not signed, because private key is supposed to be more secure than a code, it's a lot more reliable. So the projects like Cosign, these are the projects, this is one of the, let me go back as well. You can use it both for signing, verification, and storage of these container images. Yeah, it's this whole thing around PGP and signing and stuff. There's complexity there, but well, still rely on those to push the security there. So if there is an image you are using that has a signature, definitely include that in. Next up, the container daemon vulns or vulnerabilities or defects. Now, Docker engine has been notorious to have a lot of symlink attacks. In fact, one of the guys who published, well, by the way, CVEs, I'm sure you're familiar with, they are just identifiable security bugs. It comes with the year name and a number that enumerates. And one of the guys who reported lots of these symlink attack bugs, he actually lives in Sydney. And this is something that, unfortunately, by design, Docker engine is vulnerable to. Now, symlink, back in the really old days of Linux, is effectively, you could, if you were in this jailed SSH environment, which you were SSH to a box and it was jailed to a specific directory, you could create a symlink to /etc, I don't know, passwd on the host by just traversing back, like symlink .. This is like really basic example, but you could effectively read the resources. And we know in Linux, if you access to /proc, you can even read a lot more about the system, including environment variables. There could be secrets there. So kind of the adversaries were using that to pivot to other parts of the system. Now, Docker had this issue for a long time. Even when we try to segregate it using different namespaces, there were cases that when the Docker image is being built, you could have a sibling attack. That attacker was just pointing to a different file, and once the image was ready, they could just use it. So this is just something to be aware of. Again, have your container daemons patched up to date in this case, or where possible, let's not run Dockerd. Use a more safer container engines. Now, finally, this is a part that we can do the most. This is to do with our Docker manifest or Docker definition or container manifests. It's to do with insecure configurations. Now, there are a lot of things we can do here. One thing we need to remember, majority of those manifests you may find online, or the things that even the official manifest of some of the official container, like for Python, Alpine, they are not even secure by default. Like they just make the container image perhaps so slim and well with the least amount of layers, but there's nothing in terms of hardening to be done. This is just something to remember. Now I just copied this, like this one example here. Now perhaps you guys can help me to find out what are the security misconfiguration you can find here. I'll give it a 10-second. Maybe if you find something, post it in the chat.
Digest is not missing.
Of course. Yeah, you're listening. Yes, but there's something bigger than that, right? On the first line. Yeah, 4 lines of configuration. There's a security bug on every line. Put it that way. So when it comes to the weaknesses with the configuration, like I can point out to 5 of them. Now, 1, 2, 3, and 4, these are all result into privilege escalation. That the first one doesn't need to be called out. Now, I'm going to start with the first one just to clarify a few points here. And if we have time, I will dive into the remaining one. So root in a container, and I'm sure Halvard also mentioned to his talk, like, and I'm actually keen to see how Co is building those images. It used this rest non-root, which is amazing. Now, just for everyone else here, there's 2 things we need to separate out. There is a concept. There are 2 things, and they need 2 different security treatments. And I found online that sometimes we confuse between these 2. And I think hence we have still a lot of containers run as a root. So there is running a process as a root in a container versus running a container as a root. What the hell I'm talking about? Firstly, running a process as root in a container. Let's just for a few moments, we just go out of the containerized world and look back at the old days that we were running Apache servers and Nginx servers. And we know that after a couple of breaches and security problems that happened, that you should not run any Linux servers as root. You should always downgrade to a low privilege user. And that was for a reason, because if that service, say in Nginx, get compromised, well, you get adversary that may have a full access on the host. Now, in a containerized world, we have the same Nginx running in a container, and by default is root. That means when the breach happens, there is a full access inside the container, and these days you also have access to the shared resources to that container. Now let me just do a basic, a very simple demo of this, and I will share my terminal here. So I'm going to just run Docker run basic. Let's just open up a busy box, and I think that should, yeah, caching is disabled also here. So please wait for this image to be fetched. Well, that was fast. Okay. So BusyBox, vanilla image. By the way, before I run this command, let me just first run ID. So I'm a normal user, UID 1000 here. And yeah, inside the container, no digest. Yes, I know. Thanks. And inside the container, well, guess what? I'm root. So that means, let's say there is an app that is compromised and the adversary now has access to run commands inside the container. Now, as an attacker, I can just traverse through and read all the root owned resources, because why not? I'm root. Now, one thing here, just demystify a few things. Now, if you look inside proc self UID map, if you remember, I mentioned in containers, we always have, it is a process. Like, I just maybe forget about it. Maybe every time I say container, just replace that with process, because that makes more sense. It's a process. This process needs to run as a user on this machine, desktop Linux that I have. And you know that UID 0 means root. Now, this other UID here, you see, this is the mapped UID. So that means the 0 on my host, the root inside the container now is also root on my host. So effectively, whatever command that I'm running here, it's running as a root on my host. But the word view of this child process is limited. The container daemon was limited the exposure of the other resources in this container. But effectively, it's like a ticking bomb, because I am root. I'm just not seeing the other resources on the host. Now, just to further verify this, I just run a watch command over ls, and now I'm gonna move to my. This is outside the container, and if I just run this command just to see all the resources, you can see the watch ls. There we go. Mr. root. Cool. So that is one thing. The other thing, perhaps, so why this thing is happening is because, let me go back now to my other window here. Let's just have a look at some of these Docker files. Like I'm going to look at some of the official ones. Let's say the one for BusyBox, for example. I think BusyBox, is it? Yeah, so yeah, BusyBox. I should be able to, so this is a Docker official image for this. And if you just go to stable, and I think I use the Alpine version. That's it. So there's obviously one instruction missing here, that this runs as a root. But how about the other ones? Like, let's just look at, let's say, the Python one or the Go one. If I search for Python, for example, and go to 310, and let's just pick the Alpine one here, Docker file from Alpine one. That runs as a root by default. And this is just basically setting up, downloading some dependencies, nothing security-wise happening, and all the way down, some environment variables being set, no user command, not hardened. So that means, again, if you just run this Python vanilla Alpine version, we're gonna end up running this as root, and all the other things gonna follow along. Okay, so the next thing which I talked about was running a container as a root. So this is what I mean by that is the container daemon or the container service or Dockerd by default runs as a root, and historically for a reason, because it needs to set up some namespaces, it needs to set up some IP table rules for the container or networking to work. And there is there has been a huge discussion around, hey, can we do something about this? So why it is bad? Because obviously we do not want, as we know from early days of Linux, that you do not want to have any highly exposed service to run as a root. But unfortunately, Docker is one of them that is not that simple to run it as a non-root user. Now, I'm going to talk about the rootless and all the other things a bit later. So why it is important? Because Docker daemon or any Docker service behind the scene, they are nothing but a web API server. They are effectively a web server. And when we run Docker commands, effectively we are making a HTTP call to the Docker service. Why that is, for example, if I want to get the list of images that are hosted on the box, I can simply make a call to this endpoint. Well, let's just do this as a demo. And then we will find out why this is important. So I'm just going back to the same setup that I have. So exit this one. And so I'm running effectively, I think this is Docker, yeah, I think one of the latest version now. This is a Docker client, and I think for the server side, I'm also using one of the latest version here. I didn't touch any configuration, nothing, so it's just a vanilla installation of it. And but it runs. I think when I did ps-forest, I think we saw containerd somewhere here, because yeah, the containerd was actually run as root. Anyway, so one thing here, just to verify, obviously as a normal user, I can't read obviously things like that. But if we give this user access to Docker, and again, by user, you can always replace user with process. If this process has access to the Docker group, right? If the app inside the container and that container does have access to the Docker daemon, either through Unix socket or through the TCP, which is worse. Now I can go ahead, so we could see that I can read this file, the shadow file, but what if I run a container and I map the shadow file to inside container? Now the same user that didn't have access, now I'm root, and we verify that Rug self UID map is root, so I should be able to read. I'm going to quickly show this and remove the shadow file. This is my shadow file in the host, because Docker containerd runs as a root, it access to all the root owned resources. Now those root owned resources are mapped to the container, so I can read everything I want here. Now I don't have Kale here, but just to show you an example where you can actually communicate with this is for some people thinking, oh, there is no Docker client running on this container, so we should be safe. Well, you don't really need a Docker container. Your Docker container is effectively is a HTTP server, which you can even query for whatever you are interested in. Unix socket, let me see. So you run Docker, of course, this should be dot. So localhost, images. So as an adversary, once they got access to the box, they can simply, well, just navigate. I mean, I use Kale, I can use any other HTTP client just to go, and now I can communicate to that Docker daemon on the host. Now I just list the images here, but I can of course run different containers, make them as root, make them as privileged, and so effectively, few things here. Since so our containerd runs as a root, as a service. We have all these problems. And since the containerd itself is effectively a web server, you can, if we are running a web server on our box with root, really bad. And finally, if we give a user or a process access to the Docker group, effectively we give them root access. And lastly, if the containerd or Dockerd runs on a TCP rather than a Unix socket, the issue is even worse because they don't even need, the user doesn't need that Docker group privileges. They can just send this curl recommend request that I said directly to that HTTP endpoint. All right, so let me go back to my slides. Actually, I don't need to go to the slides. I'm gonna just now, perhaps we felt that all these attacks were possible because I had a shell from this container. I'm gonna do something different. I'm gonna demo a real vulnerability that, let me pick it up first. Where is my slides? Here, yep. So I'm going to pick a real vulnerability. So this is a program. I'm going to pick it from here. So if you go inside play.secteam.com container, and you pick this one, image tragic. I will paste the link here. So if anyone wants to follow, they can follow along. So I hit play and I will need to log in. So the story of this program is I'm going to show you a real vulnerable program that runs inside the container. It is vulnerable to a known security bug, which is quite fun to exploit. And then we're going to see that once the app is compromised, how remotely we can do all these attacks. So just copy this link from here. And then let me change the stop share again. I'm going to share this terminal now. Temp. So what I have here is a Docker Compose file. We will look at it a bit later. Then we have a Docker file, and we have a program which sits inside the source directory. Let's just look at the program first because we're not going to touch it. This program written in Flask, and it has the program itself does not have a vulnerability. It does only one thing. It receives an image file, and it tries to convert that image file to PNG. So that's the upload thing for that. But the way that it does the convert is by using a shell command called convert. So that's about the program. We're not going to touch it. We're going to say we have a program with vulnerability, but this program runs inside this Docker file. I think who was it? Here's the digest of the image right here, but it effectively runs this container and copies the Python file in and runs it very basic. And in a Docker Compose, well, very simple. I need to remove this one here. And we just have some port mapping, things like that. Now let me just build this. And let's see what's gonna happen. And let's run it. Perhaps it makes sense if I go to the browser. I will share not the browser. Yep. Let me share this guy here. So let's open up local port 8080. Has anyone guessed so far what the vulnerability was? Because the title of the thing was pretty obvious. So, long story short, this security bug is related to a library called Image Magic. You're most likely familiar with, but this is effectively the library behind a lot of imaging tools, like even like JavaScript, Python, the convert command on Linux, they're actually all relying on this library for doing image manipulation. Now, the vulnerability itself is called image tragic for a reason, because it was not a single, there was a series of them was published at the time. And it's tragic. And they could allow remote code execution on the server by just uploading an image file. So imagine this image file could be someone's avatar or profile, and then they upload it, and our backend code tries to resize that image. Or I don't know, someone may upload the JPEG image and we want to convert it to the PNG image. And if any of those situations could result into usage of this library, ImageMagick, by building a crafted image, which I'm going to show you how, you could actually run commands on that host. And if that command runs in a container that it runs by default as root, then all the story that we talked about. So there are many ways you can exploit this code, but one of them is by building an SVG image. Let's call it exploit.svg or MVG. I don't know if anyone is familiar with this, something like that. It's a vector image. And then somewhere along the line, you kind of include the command that you are interested to run. And the reason this exploit was successful, or in case of exploit.mg, you enter some, I don't know, these are just some instructions to create an image with the view box up on a 640, 480. But there is a command, for example, called fill that goes there and like fills the content of this from this file. But what we can see here is that there is a semicolon and like pipe, and then that command that you want to inject. So the reason this library was vulnerable in this specific CV, there are multiple of them, was because behind the scene, anytime it was seeing something like a URL or usage of field or things like that, and where it needed to go and fetch that file back, it was using this command, wget. So kind of passing that on. And then so was wget following with this percentage O, sorry, this percentage M was effectively replaced with this thing. But since we have a semicolon there, that will kind of end this semicolon there, and then the rest of the things which you had after the URL was kind of run on the host. So it's it's like a shell escaping, like you close the previous command and inject your own command. So really simple exploit, but quite a widespread impact. So they just built one of those image files. So I'm going to just copy this one here. Let me just copy this on my machine here, and then exploit.mvg, and then I'm just creating the file. So I just created a file like that, and for a command, I just picked who am I. So if I go back to this, choose a file, go to like desktop, where did I put it? Let me see. Put it in home directory. So exploit.mvg, convert. Seemingly nothing happened. But if I now head back to the terminal, so this is the container, and if you see std out, root. So that who am I command was successful, right? Now from here on, now you can effectively, you are now rooting a container, and let's just continue on. That's just, now I can simply change this exploit.mvg. Let me just also show this. So what I'm doing on this other terminal is this. So this was the original command that I ran. Which is a slight variation to what you can find it on on that website. I don't know, for some reason they didn't put the fully exploitable code, but they put, you need to find out why, but I'm just doing something simple here. Save that. Now I'm gonna open this file again and share this other one. Convert. There you go. So now I got shadow out. Cool. So I hope that made sense. I'm now gonna talk a little bit about what we can do to fix this. By the way, if you once you fix it, you can push the code to this space here. And which one I'm sharing? This one. And then this one, I'm sharing the wrong window, I think. I need to share this other one. Yeah, by the time you fix
quick peek
that
behind the curtains there.
Yeah, I know. You see all the secrets. Copy that over. So yeah, you can push it there and you get a score for this challenge. Anyway, how do we fix it? Simple. Do not run the process as root. That's not so easy with Docker, unfortunately. Yeah, they come from version 20 now. They have this rootless mode. But one of the things we can definitely do to define the user attribute, including UID and GID, let's not omit like GID, because if in some container implementation, if you don't include GID, it becomes again root by default. So, and make sure this UID and GID exist on the host. So because I've seen cases that people just put the user directive so the linter doesn't, give us the alert. But this user must exist on the host, otherwise we may map into a user that has a privilege. And typically the final instructions before run CMD or entry point, or typically CMD and entry point. So these are the things we can do. The other thing is definitely we can define in a Docker Compose file, we can define a user attribute. So at runtime, because we may not be able to modify the container image, maybe I'm just want to run someone else's container image. I can't modify that, so I can enforce them at runtime by simply modifying the Docker Compose file, specifying again UIDs. The other thing is from version 20 of Docker, we have this rootless mode, which is effectively runs the containers in a user namespace, because I mentioned Docker is just namespace behind the scene. And well, there might be some compatibility issue with some images when you want to run, especially the images that may need to have access to lower level networking and stuff, but that's something definitely you want to do. But even if you don't have access to this latest version, there was always this recommendation we had that just to use this feature called user namespaces, or effectively, if you remember when I run that cat/proc self UID mapping, the ID 0 in the root was mapped to 0 on the host. But with this user remapping, you can make that even if you run a user in a container as a UID 0, that will be mapped to a different user, mapped to a different namespace on the host. So regardless of how people run the container images or how the images are built without user directive, the root in a container is another root, is another user, low privilege user on the host. I think that's, if there is one thing we're going to take out of this talk, is effectively either run the container as rootless or define the user namespace remap. So effectively map the user to a different thing. If I want to just summarize everything I talked, if user in a container is root and container engine runs as a root, bad, like definitely, and this is unfortunately the default case. User in a container is root, container image run as non-root, well, is okay, but still there's things that they can do. The best scenario, non-root user in a container is defined. You define it with the user directive as non-root, and container itself is rootless, this is like the best ways that we want to do. So this was the level 1 of my talk. Now in level 2 of the talk, we're going to say, even in this case, there are ways for people to can elevate things, but that perhaps I can talk about it another time, because I need to talk about capabilities and all the other stuff.
Yeah, that'd be
Thank
great. We'd definitely love to have you back another time to go a bit deeper.
No worries. Yeah, so yeah, my name's my thing. If you guys like to do these things more, just last month we started a new meetup, and some of you may know me. I actually run a security meetup, but this one is a bit different. We want to encourage more people to fix security issues. So it's a 1-hour game we play, and with the goal of who is first person who can fix this security bug. A bug could be coming from, I don't know, an app, or it can be a container, or it can be Kubernetes. It depends what we bring in. That's all. Thank you.
Thank you.
Oh yeah, any questions? Yes.
Yeah, there we go. Took the words out of my mouth. Thank you so much, Pedram. Any questions, feel free to pop them in the chat or unmute and ask them yourself. We've got a few pleasant comments in the chat there and a few recommendations for books. There's one particularly from O'Reilly about hacking Kubernetes, which I think would be right up your alley, Pedram. All right, we might call it there. Thank you so much for your talk. That was really, really interesting. All right. Well, that is pretty much it for this evening. So one last thing, next meetup, it's going to be towards the end of October. We need you to speak. So if you've been inspired by anything that you've seen here tonight, or you've got something else you want to chat about, please feel free to hit me up via Meetup or via an email directly. You can find my details on the Meetup page, and we would love to have you speak. All right. Thank you again, and see you in a month or so.
Thank you. Bye.
Thanks all.
Thank you, everyone.